The foundation of our human intelligence is the ability to learn. All human progress has been the result of learning from our past efforts, evolving our understanding, and inventing new solutions. Computer scientists have been trying to get machines to learn like humans for decades. It started with a game board.
That man isn't playing checkers against a computer, is he?
Sure, and it plays pretty well.
Who's that watching?
He's Dr. A.L. Samuel, an MIT graduate now with IBM.
The first big public media breakthrough for AI was a system that taught itself to play checkers better than the guy who wrote the program, and that was in 1957.
By analyzing the data from thousands of games, the system learned which moves would most likely lead to a win. Samuel defined this process as machine learning. In machine learning, a computer analyzes data, finds patterns in that data, and uses those patterns to find the best route to a goal. As revolutionary as this work was, Samuel's ideas were limited by the data and processing power of the day. Samuel was using an IBM 701 computer with just 256 bytes of memory storage, which is about the size of today's average tweet.
And now Deep Blue has begun with Rook E1.
Correct, Rook F1 to E1.
Rook F1 to E1.
Teaching computers to play games continued to be an effective testbed for advancing artificial intelligence. And by 1996, processing power had advanced far enough for IBM's Deep Blue to beat Grandmaster Garry Kasparov at the game of chess.
And whoa, Deep Blue, Kasparov has resigned.
Also in the 90s, Gerald Tesaro of IBM helped pioneer the field of reinforcement learning by developing an algorithm that could play championship-level backgammon. His work laid the foundation for more recent AI advances in gaming. A dramatic leap in processing power, a massive increase in data, and advances in algorithms all contribute to today's AI revolution.
Things got 1,000,000 times better. 100 times was because of more computer power. 100 times was because of more data, and 100 times because of some smart mathematics that got figured out over many, many, many years. And each of those factors came together to suddenly make this sort of learning, which was slow and unreliable, relatively faster and reliable. A millionfold speed up.
And that old idea didn't work for a long period of time well enough. So data and computation really has transformed artificial intelligence into something that we can now use for a myriad of tasks.
Every day we are creating more data faster than at any time in human history. Every minute we watch over 4 million YouTube videos, conduct over 3.5 million Google searches, and tweet nearly 500,000 times.
Artificial intelligence, it's taking all this data and it's learning from it. It's doing it at a scale that we humans couldn't possibly have. I mean, we couldn't look at 1,000,000 rows of data and made any sense of it.
This massive amount of data provides endless opportunities for computers to learn, and for computer scientists to experiment and refine machine learning techniques. And because we are all contributing to the data on the internet, we are all part of that experiment.
We are swimming in seas of data. Every time we look at our smartphone, every time we click on a link on a website, all the sensors that are around us today, all of that is tracking information about our lives.
Today, AI systems are constantly tracking us and tailoring their outputs to our preferences, like Spotify curating a playlist for you, or Facebook choosing your newsfeed content. But they are also guiding self-landing space rockets for SpaceX and helping doctors diagnose cancer from radiological scans.
In the last few years, there's been spectacular progress, where many things that many experts thought were going to take decades have already happened all of a sudden. Older AI systems that beat the best humans in chess, for instance, had the intelligence mainly programmed into them by humans who knew how to play chess. The modern thing to do is instead to have the machine just learn from itself.
In 2013, Atari 2600 games like Space Invaders, Breakout, SeaQuest, and Pong were mastered by a system created by Google DeepMind, with no human input other than the rules of the game.
Google DeepMind pioneered having AIs who learn to play computer games without having any idea of what a game is, or a ball, or a player, or a score. It just got fed data for the pixels on the screen. And after a while, the same simple algorithm got superhuman performance on a whole slew of different games.
In 2017, the same technique was adapted from simple video games to one of the most complex games ever created, Go. Go, an ancient Chinese board game, is so complex that there are more positions on a Go board than there are atoms in the universe. An AI system called AlphaGo Zero learned to play Go just by playing itself, without ever being shown prior examples of games. And the choices it made to win defied anything humans had ever tried before. Whereas machine learning typically involves learning from large amounts of data, this program taught itself through the more human method of trial and error, and in the process essentially created its own data to learn from.
What was astounding about this particular breakthrough was that AlphaGo Zero was a self-taught system, that all it was given were the rules and the constraints of the game, and that's all it needed. And in fact, when the Grandmasters were looking at some of its moves, they're really quite flabbergasted, and the moves defy explanation. So artificial intelligence, and in this for all intents and purposes, is a form of artificial superintelligence, is teaching us things that we never would have been able to find on our own.